everybody, thanks for stopping by. This is Rob Riker, your instructor and mentor, and in this video, we're going to be taking a look at how a router routes. Let's go take a look at a quick agenda before we get started. So we're going to take a look at how does a router route, and then we're going to be taking a look at a packet tracer demo, where we're actually going to do a packet walk on the CLI so you guys can see exactly how this works. So how does a router route? Well, any incoming traffic received on an incoming interface is going to be placed into RAM. When it's placed into RAM, the layer 2 header is actually stripped off, exposing the layer 3 header. When the layer 2 header is stripped and the layer 3 header is exposed, so does the destination address. The destination address is actually used to reference the routing table to see if there's actually a match in the routing table for the router to use to forward the traffic with. Now, if a match is found, then the incoming interface traffic is actually switched to the outgoing interface, and the layer 2 header is rebuilt and traffic is sent outbound. Now, you might think, well, what happens if there is no match? Well, that's easy too. The router simply will drop the traffic and send an ICMP message back to the sender saying, hey, however you're trying to reach this particular destination, you can't. So please try again later. Now, let's go ahead and take a look at an actual walkthrough. So what is a router's job? It's to interconnect two different networks, whether they're local to the router or one is local and one is remote. So first and foremost, here we have our topology. We have PC1 on the left, PC2 on the right, and I have laid out all of the necessary information that you guys need to know about. So PC1 tries to ping PC2. So we send the ping message out, and this goes through from PC1 through switch 1 and then is received by R1. And if we look down here in the encapsulation portion, we have the ping, which is our payload. We have the source IP address and we have the destination IP address. Notice that the destination IP address is the IP address of PC2 and that the source MAC address is that of PC1 and the destination MAC address is of R1's gig 0/0 interface. So we go ahead and we start forwarding the traffic. Now when R1 receives the traffic, he actually takes that, strips off the layer 2 header, and exposes the layer 3 header. He looks at the destination IP address and says 10.1.2.1. Well, hey, that's a connected interface for me, so yeah, I know how to reach that. So what we're going to go ahead and do is actually change the layer 2 header to be a source of 3E02, which is router 1's gig 0/1 interface, and a destination MAC address of E1DA, which is PC2's MAC address. You'll notice that the source and destination layer 3 address, the IP addressing, does not change. It stays the same the entire time. Only the layer 2 header is ripped off and rewritten on a per hop basis. So let's go ahead and take a look at our packet tracer demo. So we'll do a packet walk with the CLI. So here we have packet tracer. And in our packet tracer demo, go ahead and zoom in here a little bit for you guys so you guys can see it a little bit better. What we have is a simple walkthrough where we want PC1 to be able to talk to PC2. Very simple. So I'm going to go ahead and click on PC1, click on the desktop, and I'm going to click on the IP, the command prompt. Type in ipconfig, and we can see that we have our IP address, we have our default gateway. If we ping 10.1.2.10, what do you think is going to happen? Is the traffic going to be permitted, or is it going to be dropped? Well, let's go find out. Not looking too good right now, but let's wait for it. Oh, and there it goes. So let me ask you a question. How come this very first entry, request timed out, shows up? What does that mean? Do I need to be worried about that? No, you don't. What that first entry means is that when PC1 tried to communicate with PC2, he said, I don't know how to reach PC2. But what R1 did, R1 said, you know what? That's okay. I know how to get there. So just point yourself to me and I'll get you there. So what ended up happening, if we look at an ARP-A, let me scoot this over just a little bit for you guys to be able to see it. If we look on the ARP table, we can see 10.1.1.1 and we can see 3E01, right? That MAC address shows up on PC1. Now, what MAC address is that? If we click on R1, go ahead and pull that up real quick. Click on R1. If we go to the CLI and we come down here and we do a show interface gig 0/0, we can see that 3E01 is the burned in address, or the layer 2 header, layer 2 MAC address of gig0/0. So when the traffic comes in and we do a show ARP, we're going to see a couple things. Go ahead and squeeze this over just a little bit so you guys can see it a little bit better. Scoot this down and scoot this up. So you'll notice that if we look at the ARP table on router 1, that we can see the IP, our default gateway, and that's what this dash is indicated by. We also can see the layer 2 header, the IP address of PC1 and the IP address of PC2. But you'll notice that the MAC addresses here are reachable via those same interfaces, and we see that we have a IP to MAC binding. So ARP is working. So effectively, what the router will do is the router will say, you know what, any networks, networks or hosts or destinations that you need to reach that are not on your same subnet, you're going to insert my layer 2 address into your destination layer 2 header. And what that's going to do is you're going to forward the traffic to me, and then I'll worry about getting it forwarded to somebody else. That's what they refer to as proxy ARP. Proxy ARP says, point yourself to me and I'll get you to where you need to go. That's the idea here. So the layer 2 header is ripped off. The layer 2 header is rewritten as we go through the packet walk. And if I do a show IP route for 10.1.2.10, we're going to see that there's a route in the routing table. And the route in the routing table says, you know what? It's a connected route first and foremost. And what we need to do is we need to point that traffic out gig0/1. Right? Gig0/1 is directly connected to router 1, so we know we can forward the traffic out that direction. So the traffic is moved from the inside interface to the outside interface, or the gig0/0 interface to gig0/1, and then forwarded off to PC2. PC2 then receives that traffic and is able to respond back, and the reverse process happens. PC2 sends traffic to router 1 on gig0/1. Gig0/1 removes the layer 2 header, switches that traffic from gig0/1 to gig0/0, rebuilds the layer 2 header, and then sends that traffic back out towards PC1, and voila, we end up having a end-to-end ping. And it works continuously. Now, would that happen if we do the same thing for .30, which is PC3? Yep, because we have to still do an ARP resolution. But what's going to end up happening is R1 is going to reply with its MAC address. It says, you know what? For anything that you need to go through me to get to, point yourself to me. And that's all we have to worry about. That, ladies and gentlemen, is how a router routes. So what we covered in this video, we took a look at how does a router route, and we also looked at a packet tracer demo. It was a pleasure and an honor to be able to hang out with you in this video. And until next time, guys, take it easy.
Jacob Hess here. Thank you guys for viewing the video. I hope you really enjoyed it. And I'd also like to remind you that if you're truly serious about your career in information technology, be sure to check out our Career Blueprint and Engineer Training Program at www.zerotoengineer.com.